All right, if you remember, this was from last week, maybe even the week before, when we were multiplying a binomial by another binomial. And I know some of you used the area model for this process, while others used distributing. And then there were some of you that chose to use FOIL, right? Oops, sorry. The first, the outer, the inner, and the last terms. And so if I multiplied these two binomials, I would get x squared plus 3x plus 4x, which is where this 7x is coming from, and then plus 12. So that's what we've done previously, and here's what we're going to do today. We're going to take the ending result there, that trinomial, and factor it into where it would have started. Again, this process is called factoring, and that puzzle that you've been doing previously in this lesson, where you look for the numbers that you multiply to get 12, that you add to get 7, should work, right? The two numbers that you multiply to get 12 are 4 times 3, and because 4 plus 3 is 7, then this trinomial factors into x plus 4 times x plus 3. So whatever these two numbers are, go here and here. And again, this should tell you if they're both positive or negative numbers. It was 4 times 3, that's 12, and 4 plus 3, that's 7, so they're both positive. And then because the first term here was x squared, well, the only way to get that is to multiply x times x. Again, this is what our factored form is going to look like today. I'm going to scroll ahead a couple. And so, again, the pattern that we're looking for is what multiplies to get our last term, c, and what two numbers then do you add to get that middle term's coefficient, which we'll call b. So now, let's do this one together in your notes. Again, the pattern is what multiplies to 45, that adds up to 14. Now I could list all of the possible factors, all the possibilities, any two numbers that you multiply to get 45. You might see the two that work right away, but if you don't, just keep listing, right? 1 times 45 is 45. 3 goes into 45 15 times. 5 times 9 is 45. And now I found the pair that adds up to 14. So that's the pair that we use. Again, we can set up our binomial factors because this time this is a squared, then we know that each of our first terms is a. And because this is a positive 5 and a positive 9, we know that in one of the binomials we write plus 5, and in the other one we write plus 9. And just so you're aware, that is the exact same as writing it in this order, a plus 9 times a plus 5. These are both correct. Let's try the next one. This time we need to multiply to get -8 and add up to get -2. So I'll show my thinking over here. If I multiply to get a negative, I know that one of the factors is negative and the other one is positive. I know that 8 times 1 is 8, so -8 times 1 is -8, and 8 times -1 is -8. Neither one of those adds up to the -2. So we keep checking, right? 4 times 2 is 8, so -4 times 2 is -8, and 4 times -2 is also -8. And the pair that adds up to this -2 is -4 and +2, which makes this trinomial factor into x minus 4 times x plus 2. It's a -4 because it was a -4, and a +2, so it's a +2. Again, you can switch that order around and write x plus 2 times x minus 4, but no matter how you write it, the 4 has to be with the minus and the 2 with the plus. And then finally on this page, we're looking for factors of negative 20, numbers that you multiply to get negative 20, that you add to get positive 8. Again, when I know it's a negative product, I know that I need one of the factors to be negative. So 1 times 20, I could check it with the 1 being negative, I could check it with the 20 being negative. Neither one of those adds up to positive 8, so I keep checking. 2 times 10, if I make the 2 be the negative, negative 2 times 10 is negative 20, and negative 2 plus 10 is positive 8. So it factors into m minus 2 times m plus 10. All right, on the next page, you're going to get to try some of these on your own or with a partner, and then come back and take a look to see how you did.